Virtualization Overview. In this section, we will define virtualization and look at the various types of virtualization that exists in the marketplace. This is a 50,000-foot view of what virtualization is and the different types of virtualization, and not really getting into the details of any specific type of virtualization, which we'll cover in the next sections. So what are the objectives? We will define virtualization. We'll look at the various types of virtualization. We'll introduce the concept of server virtualization. And then we'll bring in the concept of a virtual machine. Then we'll look at virtualization from a historical perspective. We'll look at the features of virtualization. And then what are the modern applications of virtualization. Virtual. What I did was looked up the definition of virtual in the dictionary, and it said very close to being something without actually being it. That's virtual. Being such in power or effect, though not actually such. So virtual really means it's something that's really not there. It's just giving you a vision of it being there. Think of the Superman movie where Superman is talking to his grandfather, which is a virtual figure, right? So that's an example of virtual. Now, what does it really mean when we say virtualization in information technology? It's the simulation of physical computer parts. It's the simulation of CPU, memory, disk, network, firewalls, routers, no matter what it is. You can simulate it, and that's what virtualization is. It accomplishes the same goals as physical resource. For you, it will look like a physical server. For you, it will look like a physical firewall. So from that perspective, it is going to accomplish the same goal as a physical device, but it's really virtual. One of the key characteristics of virtualization is that it exists only in the memory of a computer, which means it's really physically not there. Virtualization has become an important technology in modern IT systems. It has become a proven software technology, rapidly changing the IT landscape, both from modernizing the data center and also in terms of cloud computing. It is the founding technology for cloud computing. It enables cloud computing. You will see when you launch servers within your Amazon EC2 or Google Compute Cloud, you get these servers. How do you get them? Well, you get them because virtualization is being done behind the scene to give you an instance of a server. Virtualization is not cloud computing, although many people kind of mix the two things. They're not the same thing. One enables the other. Virtualization enables cloud computing. It's truly changing the way people compute, whether it's operating system or a server or a storage device or a network device, like firewalls or load balancers. There are actually different types of virtualization. There is process virtualization. In process virtualization, you have language level virtualization. For example, Java platform, .NET platform, and Smalltalk platform. They all said you could write your program in Java or .NET or Smalltalk. You compile it, and then you get these bytecodes, and these bytecodes run in some kind of a virtual machine, like the JVM for Java, or for .NET, you had the CLR, which is the common language runtime. And then you also have a virtual machine for Smalltalk. So that's language level virtualization. There is also OS level processes. For example, Solaris, Zones, BSD jails, Virtuoso were all containers that made you run process in a specialized environment. It's almost like a sub-operating system process. Then there's also I/O device emulation. For example, you can emulate storage, so that's storage virtualization. Logical storage versus physical storage like Loon or RAID. You're looking at storage as a virtualized environment. An example of storage virtualization is SAN network, which is storage area network, or the NAS, which is network file systems. There is also network virtualization. With network virtualization, you're actually building logical networks over physical networks, so you can get things like VLAN, VPN, and NPIV. So these are examples of network virtualization. And then there's also server or process virtualization, where you're basically taking a server which has CPU, RAM, hard disk, network, and you're virtualizing it so that you can run multiple servers on them. And there are two kinds within them. There's the hosted and the bare metal virtualization. we're going to be talking about server virtualization a lot more detail, because that's one of the key founding technology for data center modernization and cloud computing. Then there is also storage, network, desktop, application, many other kinds of virtualization that's available. So the point I'm trying to make is virtualization is a pretty big field. There are different types of virtualization. But let's quickly look at server virtualization. Server virtualization is the ability to run multiple operating systems on a single machine. Basically what you do is you take a single physical machine which has CPU, RAM, network card, hard disk, and you kind of chop it up into sub-machines or several virtualized servers, and you can run an operating system in each one of them separately, and they all think that they have their own copy of CPU, RAM, network device, and hard disk device. Every one of them thinks the same. That's the idea behind server virtualization. Breaking a server or a single machine into several sub-logical machines. That would be server virtualization. Now you might be thinking, well, server virtualization looks like dual boot. Well, server virtualization allows you to run multiple operating systems at the same time, whereas dual boot allows you to run multiple operating systems, but not at the same time. You have to either boot operating system 1 or operating system 2 and run it. And when you want to shift between the two operating systems, you literally have to shut down one and restart the other, which could be time consuming. So dual boot is the ability to run multiple operating systems, but not at the same time. Let's look at the traditional model. In the traditional model, you have the hardware, and the hardware of course has the CPU, the memory, the NIC card, and then the hard disk drive. You load the operating system on top of it, and then you run applications on top of the operating system. Now in this model, which is what we call the physical model, the traditional model, the resources are often grossly underutilized. You may have a machine running 4, 5, 6 different processes, but the machine is not being utilized in terms of CPU or RAM, NIC, or even the disk. And one of the reasons for that is Moore's law, which is every 18 months your hardware is becoming more and more powerful. And as you bring in these new kinds of hardware, because you have to rotate your hardware from time to time, you end up having servers that have a lot of capacity. In terms of software, it's tightly coupled to the physical hardware. In the olden days, we used to have a server, install the operating system on top of it, install software on top of it, and then if you decide to take that particular hard drive and move it to a different machine because your CPU fried or your network card fried, it was a big hassle. You just couldn't do it because the operating system was tied to the hardware. Everything was tied to the hardware. Now let's look at the modern way. In the modern way, in the new way, we have the concept of a virtual machine. This is all the idea behind server virtualization. In this model, you have your physical machine, and the physical machine has the CPU, the memory, the NIC card, and the disk. But then you add a new layer called the virtualization layer. This virtualization layer is going to encapsulate all the hardware from the operating system. It's an extra level of indirection between the operating system and the actual hardware. It actually decouples the hardware from the operating system. It gives you isolation, and it's also multiplexing the hardware across these different virtual servers or virtual machines, which can have its own operating systems. So what you're really doing is you're taking an existing machine and chopping it into pieces so that you can run multiple operating systems on them. So what are the properties of virtualization? Virtualization gives you abstraction. Your operating system is independent of the physical hardware. That enables you to do migration of VMs to other hardware. It also gives you partitioning or isolation. There is system level partitioning, so you're able to run multiple operating systems within the same machine. And it's also giving you isolation in terms of fault, performance, and security. If one of the virtual machines fails, if one of the virtual machines has a security issue, it's isolated to that particular virtual machine. It also gives you encapsulation, which means it cleanly captures all the virtual machine state, and this virtual machine state can be actually stored in physical files and restored in a different machine. This gives you the preface for VM snapshots, cloning the machine, and also enabling live migration of VMs to other hardware. A VM may be running on one machine and you can just move that VM to a different machine because that current physical machine is being overutilized. It also gives you what is called interposition. Interposition is when somebody is sitting in between. Because the hypervisor is sitting in between the virtual machine and the hardware, it can transform instructions from the operating system in terms of memory instructions, I/O instructions, CPU instructions, and do whatever it wants to. Well, what can it do? Well, it can do what is called overcommitment. It can give the illusion to the virtual machine that it's got more memory than what there is. It can do encryption, it can do compression, it can do replication, security, monitoring. All kinds of things come into play when you can inject something in between, and that's what interposition is all about. So virtualization is a pretty cool concept from that perspective. The first virtualization was accomplished in the 1960s on IBM mainframes. It was actually pioneered by two engineers, Gerald J. Popek and Robert P. Goldberg, who actually published a paper in 1974 called Formal Requirements for Virtualizable Third Generation Architectures. This is the link for that paper. It's actually a paid link from ACM. You're welcome to pay for it and download the paper, but I'm going to give you the key characteristics of this particular paper. In the paper, Popek and Goldberg describe the concept of a virtual machine, and they also introduce the concept of a virtual machine monitor. As part of this paper, they basically say that there are three characteristics of virtual machine monitor, which today we call hypervisor. We call it hypervisor. We'll learn more about hypervisor in a further section. This virtual machine monitor, they say, should have three characteristics: fidelity, performance, and safety and isolation. Now, what's fidelity? Fidelity is accuracy or exactness of imitation. Basically, what they say is that a virtual machine monitor should mimic an actual machine. The operating system should have no idea that it's actually working on a virtual machine. And that's really what fidelity is. They also say that performance becomes an important aspect. When a virtual machine monitor is simulating a physical machine, it should be highly performant. It should give the computer an illusion that everything is working really well. So performance is an important aspect of it. And then it should also give safety and isolation, which means if something happens to a virtual machine, it should not destroy the other virtual machine. This was a very important paper where Popek and Goldberg described the concept of a virtual machine, and then they described the concept of a virtual machine monitor, which is really your hypervisor in modern times, with three key characteristics. Now let's look at the classic virtualization and applications. The classical VMM or virtual machine monitor was done in IBM mainframes on IBM S360 and IBM VM370. It was designed primarily on proprietary hardware OS for IBM, and they used what is called the trap and emulate model, where basically they would trap any instructions that would have to run in a privileged mode, and they would basically execute it in the VMM and return back to the logical operating system. We'll talk a little bit more about this when we get into hypervisors. The classic applications that they built were time sharing several single user operating system instances on an expensive IBM hardware, or compatibility across various IBM hardware. In those days, IBM used to come up with new generations of hardware, and it was very important for them to make sure that their customers can actually run their existing operating systems and programs in the newer hardware. So they needed some kind of a virtual machine layer. And that's why they actually did research on virtualization. Now let's look at modern virtualization renaissance. There is a recent proliferation of VMs everywhere. Virtualization used to be considered as an exotic mainframe technology in the 1990s, but now it's everywhere. It's in every data center, it's in the cloud environments. It's a huge commercial success. And why is that? The reason for that is the introduction of the commodity x86 hardware, and of course the innovative capabilities that are there with these new hardwares and the new computing capabilities that you have. You're able to get servers now with 32 gigabytes of RAM, with 8 cores, all for $5,000. And your applications haven't changed much. So you're able to do more with less with virtualization, which saves you money. And the virtualization is an extremely versatile technology in terms of the cloud. You'll see how it enables the cloud too. So it's become very important in today's world. Classic virtualization applications in the modern world is server consolidation, which is convert several underutilized servers to VMs running in one physical server. That allows you to save money, space, power, all different kinds of things that you will have to do for a physical server. It's also being increasingly used for virtual desktops. We'll later on talk about desktop as a service. There is also simplified management. If you're going to have 1,000 machines, and now with virtualization, you only need 100 machines, then your data center provisioning and monitoring and load balancing, all those things have become much, much more manageable. It's simplified management. Also improved availability. You can do several things with virtualization. You can do a restart of a virtual machine all from a console. You can move a virtual machine from one physical hardware to another physical hardware. Fault tolerance, disaster recovery, all kinds of things can be done with virtual machine, which we will talk about later on. And you can also do test and development. You don't really need physical machines. You just launch virtual machines, you do your testing, and then you're done. You move away. Your testing and development environments can now be virtualized environments. So in summary, virtualization is the logical view of physical IT infrastructure. There are different types of virtualization. There is server virtualization, storage virtualization, network virtualization, application virtualization, desktop virtualization. But server virtualization is the most important one. We'll talk more about that. The concept of a virtual machine is really a logical view of a physical machine. Server virtualization, which is an important technology, is really launching multiple virtual machines in a single hardware. This was not something that started yesterday or a couple of years ago. It's been in the works since the 1960s, and success came in the 1970s. In terms of features, virtualization gives you isolation, which is really separating out each virtual machine in an individual instance, and failures and security issues and performance issues are all isolated within that particular virtual machine. There's also encapsulation. There's encapsulation of virtual machine from the physical hardware. There is also portability. You can easily port one virtual machine from one physical hardware to another physical hardware. There is also interposition. Interposition is basically interfering between the virtual and the physical. That's the hypervisor layer, which brings you a whole bunch of new concepts or new features, including monitoring, security, live migration, and things like that. And then finally, there are several modern applications of virtualization like server consolidation, simplified management, improved availability, test, and development.